Welcome to Your Math Explained, where we make math simple and clear. My name is Julian, and today we'll look at two algebra problems that involve ratios and fractions. The first problem is for grade 9-10 students, and then the second problem is for grade 11 and 12 students. In both problems, we rely on converting ratios into solvable equations. Pause the video now if you haven't had a chance to read it, otherwise, let's jump in. We are given two packages here. In the red one, we know that there's a ratio of cinnamon to sugar of 1 to 3. So this tells me that we have 1 part cinnamon out of 4 total parts. That's cinnamon. And we have 3 parts sugar out of 4 total parts. This is for the red package, and we can do something similar for the blue package. The ratio is 1 to 4, so that means we have 1 out of 5 for cinnamon. And we also have 4 out of 5 for sugar. We're being told that we have 1 package of this red one, so I'm just going to write that down here. 1 package of the red and 2 packages of the blue, and then we're creating a mix. One important point to make note of is that these packages are calculated based on mass, and we know that both packages actually have the exact same mass. That's going to inform us of our equation going forward. So we're going to let x be the mass of the package. Then, what we know about the cinnamon parts would be that we have 1/4 x, so 1/4 of the original package, plus, instead of doing 1/5 of the next package, we're going to do 2/5 of it, because we have 2 of those packages. So I'm just multiplying that fraction by 2. And because it's the same mass, it would also be multiplied by x. This will give me C. And what does this C actually mean? Well, C obviously is related to cinnamon, but specifically, this is the total mass of cinnamon. We can do something similar to create another equation for the sugar. So we've got 3/4 x plus, instead of 4/5 x, we're going to do 8/5 because we have 2 of those packages, so we're multiplying that by 2, equals s, and this would represent the total mass of sugar. Now, if we were to simplify both of these equations, we'll see that equation 1, once we give it a common denominator, that would be 5 plus 8 over 20. So that works out to 13 over 20x equals to C. And equation 2, if we give it a common denominator, we'll see it's 15 plus 32, which makes 47 over 20x equals S. These are the expressions that we've got for cinnamon, and also the expression for the mass of the sugar. So for us to figure out the ratios of cinnamon to sugar, we can just write 13 over 20x to 47 over 20x. And getting rid of the x since it's showing up on both sides, getting rid of the 20 since it's showing up on both sides, that tells us that the ratio is 13 to 47. In the second problem, we are given fractions to work with no ratios. So this means we're probably creating some sort of fractional equation with the information that's given. I'm going to let R and B be the original number of raspberries and blueberries. since those are the fruits in question. And we are going to create an equation, or maybe multiple equations, based on these variables. The first statement that is useful is about Natasha. We have Natasha adding 10 more raspberries to the bowl and determined that 3/10 of the berries in the bowl were raspberries. So what that tells us to set up is something that's related to 3/10. Specifically, the number of raspberries on top and the total number of berries on the bottom. The total number of raspberries would be R plus 10, the original amount plus 10 more. On the bottom, the total is R plus B, so the amount of the two types of berries, plus we've just tossed in 10 more. This is my first equation. We'll just write a little 1 here. We'll come back to this. In the second statement, we know Jing added 20 more blueberries to the bowl, and we've got a quarter of them that were raspberries. So we can create a similar equation. We have 1/4 as our fraction. The number of raspberries haven't changed. It's still R plus 10. On the bottom, we have R plus B plus we have 10 and then another 20 berries that have been added, so 30 on the bottom. This will be equation number 2. In both instances, it's probably easier to process the equation without the fraction, so I'm going to cross multiply here, and then we'll try to simplify each equation. So I'll have 3R plus 3B plus 30 equals 10R plus 100. So when we move some things around, we are going to get negative 70 equals 7R minus 3B. Similarly, in the second equation, we'll have R plus B plus 30 equals 4R plus 40. Simplifying will give us negative 10 equals 3R minus B. We now have a system of equations. So taking equation 3, and then we are going to subtract 3 times equation 4. So 3 minus 3 times equation number 4. We are going to remove the b's. This will give us negative 2r equals negative 40, which means r is equal to 20. And if we have r, we can sub it back in to find b, and we'll actually get that b is equal to 70. Since the original problem was asking us for the number of raspberries in the bowl, that would tell us that it is 20 over 20 plus 70, the number of raspberries and blueberries in the bowl. That would be 20 over 90, which then reduces to 2 over 9. That wraps up this week's problems. Check out the problems I've posted for next week's video. Try them on your own first and see how you'd approach them. And as always, if you found this helpful, don't forget to give the video a like and subscribe so you don't miss the next one.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.